Good morning, guys. Today we're going to be looking at the third and final method of solving for systems of linear equations. This one is called elimination. Okay, so with elimination, just like with substitution, if there are fractions that you would like to get rid of, you can multiply each term by the denominator. And then you want to make sure that one variable has the same coefficient in each of your two equations. And in order to get them to be the same, you may need to take an entire equation and multiply it by a whole number. Then you want to make sure that the equations are arranged the same way so that the constants are in the same spot and any variables are in the same spot. And then you need to either add or subtract the two equations so that one of the variables cancels out. If the coefficients of that variable have opposite signs, so if one is a positive and one is a negative, then you will add the two equations. If the coefficients of that variable have the same sign, so they're both positive or both negative, then you will subtract. Your next step is to solve for the remaining variable. So whichever variable didn't get canceled out, that's the one that you'll solve for. You'll then plug that solution into the other, into either of the other equations that you started off with in order to solve for the other variable. And then of course at the end, if you've got time, you can verify using left side equals right side. Okay, so this is the first example here. So we've got y equals negative 2x minus 7 and x plus 3y equals negative 3. So the first thing that I'm going to want to do is to pick either my x's or my y's to be the same. Doesn't matter which one you pick. I think I'm going to go with the 2's just because why not? So that means I want my x's to be the same. So in order to do that, that means I need to get either a 2 or a negative 2 in front of the x in this equation, which means I need to take the entire equation, x plus 3y equals negative 3, and multiply it by either 2 or negative 2. And because I like working with positive numbers, I'm going to multiply it by 2. So that'll leave me with 2x plus 6y equals negative 6 as my first equation. And then the other equation, I just want to rearrange it so that it looks similar to this. And it doesn't matter really how you rearrange these as long as the x's, y's, equal sign, and constants can all line up. So if I just add 2x to move this to the other side, I can rearrange this first equation as 2x plus y equals negative 7. And now in both equations, I have my 2x, and then my y, and then my equal sign, and then my constant. So those are the first things that we've got to do just to make sure that our equations are set up properly. And again, we want one of our variables to be the same in both equations. And so I've got a 2 in front of my x in both equations, so that's great. I could have also made the y's the same instead of the x's if you wanted to, so whichever you rather. The next step, so I've got my two equations now. The next step is going to be to stack those equations on top of each other. It doesn't matter which one goes on top. Stack them on top of each other like that. And then I need to either add or subtract them in order to get, in this case, my x's to cancel out. Whichever variable has the numbers that are the same, you need to cancel that one out. So because these are both positive 2's, in order to get them to cancel out, I'm going to have to subtract. So 2x minus 2x cancels out. Then I go over to my y's. So y minus 6y is going to be negative 5y, because remember this is a 1 in front of that, so 1 minus 6 is what that really is saying. And then negative 7 minus negative 6 is negative 1. Of course, then I need to isolate my y. So I'll divide by negative 5. And that leaves me with y equals 1/5, because these negative signs will cancel out. Then I'm going to go over, as step 4, I'm going to go over to either of my original equations, doesn't matter which one I want to use. And I'm going to plug in this y value, wherever that is, okay? So I'm going to go to this first equation up here, but again, it doesn't actually matter which one you use. So I'm going to have y equals negative 2x minus 7, so that's 1/5 equals negative 2x minus 7. And then just because I hate working with fractions, you don't have to get rid of your fractions, but I hate working with them, so I'm going to multiply by 5 right now, which leaves me with 1 equals negative 10x minus 35. And then I'm going to start isolating x, so I'll add my 35 to move it to the other side. That leaves me with 36 equals negative 10x. And then, of course, we just divide by negative 10. Divide by negative 10. And that can be simplified as negative 3.6, or if you'd rather keep it as a fraction, negative 18/5. Okay? Okay, in this second example here, as you can see, one of my equations has a fraction. So my first step is to get rid of that, and I do so by multiplying every term by the denominator, so by 2 in this case. That will leave me with 7x plus 2y equals 20. And then on the other side, 4x minus 3y equals 20. And actually, I'm going to change this. Yeah, I'm going to change this to 40, so my constants don't cancel out. There we go. The next thing that I'm going to do is pick to get either my x's or my y's the same as each other. Now, in order to get my x's to be the same, I would have to multiply this first equation by 7 and this second equation by 4, and I would end up dealing with some pretty big numbers, especially in the first equation. In order to get my y's to be the same, I just have to multiply the first equation by 2 and the second equation by 3. So I'm going to pick to make my y's the same. And so again, for this first equation here, I'm just going to take the entire equation and multiply it by 2. And then for the second equation over here, I'm going to take the whole thing and multiply it by 3. And of course, we just multiply into the brackets. So 2 times 4x is 8x, and then minus 6y equals 80. And then in the other equation, again, that's going to get multiplied in. So I'll end up with 21x plus 6y equals 60. Okay, And now my coefficients in front of my y's are the same. Now you'll notice one is negative and one is positive, and that's okay. Though I certainly could have multiplied this by -2 or this by -3 if you wanted them to be the exact same. Then I just make sure that I've got x's, y's, equal signs, and constants all in the same spot, which I do, which means I can move on to my third step, which is stacking these on top of each other. Like so. Now this time, unlike last time where I had to subtract in order to get my variables to cancel out, this time, because they have opposite signs, because one is negative and one is positive, I'm actually going to add in order to get these to cancel out. So 8x plus 21x is 29x. My y's have canceled out because -6 plus 6 is 0. And then 80 plus 60 is 140. And then, of course, to get the x by itself, I need to divide by 29, like so. And 140 divided by 29. Again, you can keep it in fraction form if you would like, or you can write it as a decimal, though if you do that, make sure you keep lots of decimal places. Or just keep it in your calculator so you can use it in the next calculation. So step 4 is to go back to any of our equations and plug in the x value that we just got. So I'm going to go back to maybe this equation up here. It doesn't matter which one you pick. So I'll do 7 times 140 over 29 plus 2y equals 20. And then 7 times that will give me roughly 33.79331. And then, of course, I'm going to need to subtract that to get my 2y by itself. And so that will leave me with 2y equals negative 13.7931. Yes, excellent. And then, of course, we divide by 2. So your y is negative 13.7931. Okay, once again, you could keep those in fractions if you wanted to, but with numbers this complicated, with this big of fractions, don't worry about it as long as you keep a couple decimal places. Okay, that's all for today.